Hey guys, so we're going to continue with volume today in the form of word problems. If you were not here on Friday, no big deal. All we did was we covered how to find the volume of a cone and a sphere, and it's the same way as you find the volume for a cylinder or a prism. They're just different formulas. So these formulas should be written down on your notes page already for you, so don't worry about writing these down. One thing I do want to make sure that we're getting, because some of us are leaving this off, whenever you're finding volume, you need to write whatever the units are at the end of it. So let's say you're finding the volume of a cone, and its radius and height are measured in centimeters. Your volume has to be whatever the number is, followed by centimeters cubed. And remember, volume is measured in cubic units because it's three-dimensional. So make sure that all of your problems today are followed with units. That's how you're going to have to do it on Park, so that's how we're going to have to do it in class. All right, let's go into an example. All right, let's read this first one. A company packs its coffee into cylindrical containers. The height of each container is 6 inches and the radius of the container is 3 inches. Which is closest to the volume of one of these cylindrical containers? Use 3.14 for pi. Okay, so whenever I hear a shape, the first thing I'm going to do is draw it. So here's my little coffee container. I know that it has a radius of 3 and a height of 6. Now all I have to do is plug it into my formula. So V equals, I'm using 3.14 for pi. My radius was 3, raise that to the second power, times our height of 6. Before I multiply this out, I'm going to go ahead and simplify this down. So I'm going to bring down my 3.14. 3 squared is 9. And then I just bring down my 6. Now, if I multiply this out, use your calculator, you're going to get approximately 169. So our best answer for the closest volume is going to be D, 170 cubic inches. All right, let's move on to the next example. Oh, and I didn't put this here, 169 cubic inches. Cool. Let's go on to our next example. All right, you buy 2 cone-shaped hats with different dimensions for the same price. Hat 1 is 2 feet tall and has a diameter of 4 feet. Hat 2 has a radius of 3 feet and is 3 feet tall. Which hat has a greater volume? First thing I'm going to do is draw these. All right, so these are cone-shaped hats. This will be hat 1. And then I have hat 2. Now, it told me that hat 1 is 2 feet tall. Go ahead and draw my height there. Label it with a 2. And has a diameter of 4 feet. Now, I know that if the diameter is 4, the radius must be 2, because the radius is just half the diameter. Then I have hat 2, which has a radius of 3 feet and a height of 3 feet as well. Now what I have to do is figure out which one has the greater volume. So I'm going to use our formula, which is V equals 1/3 pi r squared height. So I'm going to find the volume for the first hat, you're going to find it for the second hat, and then you're going to tell me which has the greater volume. So if I go ahead and use my calculator and simplify 1/3 down to a decimal, it's going to come out to 0.33, which I can just use that and simplify that down. Pi is 3.14. We had a radius here of 2. We'll raise that to the second power. And we had a height of 2, and there should not be a power there. A height of 2 as well. Now, let's simplify this down even more and get rid of that exponent. Bring our 1/3 down. Bring our 3.14 down. 2 squared is 4. Bring down our height. Now, I'm going to punch it into the calculator. .33 times 3.14 times 4 times 2 is going to give me approximately 8.3, if I'm rounding, cubic feet. Because that was our, so we'll have feet cubed. So that's the volume of our first hat. Now you're going to find the second hat. All right, so if I multiply out the volume of hat 2, you should get roughly 27.9 feet cubed. So obviously hat 2 has the greater volume. All right, guys, all we're doing is using formulas, finding volume. Today's going to be a lot of time for practice. So let's go ahead and get to it.